Okay, Assalamualaikum. So today's focus is the steps in factor analysis, which is we recall what we have learned before this in doing the factor analysis. So actually this is the last part in factor analysis. Okay, there is the 4 steps in doing the factor analysis, which is the first step adalah the correlation matrix for all the variables is computed. Okay, we do the first step is to see whether there is a correlation between the variables. So we need to observe the correlation matrix for all the variables to see whether there is a correlation between the variables. Okay, if the correlation matrix using the correlation matrix ataupun from the correlation matrix we can see which variables correlate to the other variables. Okay, if the correlation matrix ataupun if the value of the correlation is very low, which is less than 0.3, less than 0.1, so it seems that there is no correlation between the variables, so no need for us actually to proceed with the factor analysis. So first of all, we can check the correlation matrix for the correlation between the variables. So actually we have three methods to check for the first step, which is using the correlation matrix, or using the test, which is the KMO and Bartlett test. Okay, after this I will show you how to conduct the test. Okay, the second one is the factor extraction. Okay, as you learned before this, we can see how many factor will be extracted to represent all the variables. Okay, so we have p variables, and we want to know how many component that will represent all these p variables. So maybe daripada p variables, daripada let's say 12 variables, kita hanya akan extract the 3 component. Okay, so daripada situ we can the next step nanti kita akan tengok which variables go to which component. Okay, itu yang kedua. Yang kedua kita nak tahu how many component will be extracted. Okay, the third step is the factor rotation. Okay, we are doing the factor rotation to see clearly which factor, which variable belong to which factor. Okay. Okay. Yang keempat, make the final decision about the number of underlying factors. Okay, from the rotated component matrix, we can see which variables belong to which component, and from that you can name the new component ataupun the new factors. Okay, with the unique name. That is the 4 steps in doing the factor analysis. Okay, so I will focus on the first step, which is the correlation matrix, which is we want to see whether the factor analysis can be proceeded or not. Okay, because of first of all kita kena tahu dulu whether the variables are correlated or not among each other. If there is no correlation between the variables, there is no need for us to do the factor analysis. Sebab apa? Sebab factor analysis ni kita nak tengok from p variables, kita nak nak groupkan the variables that correlate to each other ke dalam component yang lain. Okay, so because of that we want to know we need to know there is a correlation between the variables. Okay, if there is no correlation between the variables, okay, uncorrelated variables, so no need for us to proceed with the factor analysis. So the first step is very important. Okay, the first method we can generate the correlation matrix for all the variables and identify the variables not related to each other. So actually we can delete the variables that not related to each other. So how can we know? Using the value of correlation lah. Okay, whether if the correlation between the variables are very low, less than 0.3, less than 0.1, so kita boleh delete actually. Okay, if the correlation between variables are small, it is unlikely that they share common factors. So kalau dia not correlate among each other, so maybe dia tidak termasuk di dalam faktor yang mana-mana nanti bila you dah extract. Okay, correlation coefficient greater than 0.3 in absolute value are indicate of acceptable correlation. Okay. Okay, itu the first step. Secara generally kita boleh tengok daripada correlation matrix. Okay, ataupun we can use these two tests using the Bartlett test or the value of KMO. Okay, to determine the factorability of an intercorrelation matrix. Okay, so before we are doing the factor analysis, should be you check dulu these two tests, Bartlett test dan juga KMO, nak confirmkan whether we can proceed with factor analysis or not. Okay, so what is Bartlett test? Okay, Bartlett test is used to test the hypothesis of the correlation matrix is an identity matrix or not. Can you imagine the identity matrix? All the main diagonal is 1 and the other element will be 0. Okay, correlation matrix adalah identity matrix. So means that bila all the main diagonal is 1 and the other element semuanya 0, means that there is no correlation between each other. Betul tak? So kita punya hash note adalah the correlation matrix is an identity matrix. Hash 1-nya will be the correlation matrix is not an identity matrix. So yang kita nak dekat sini adalah we reject hash note. Kan kita nak accept hash 1, which is the correlation matrix is not an identity matrix. Kalau identity matrix maksudnya there is no correlation lah between the variables. So kita nak reject hash note. Okay, if the value of the test statistic is large and the associate significant level is small, it is unlikely that the population correlation matrix is an identity. So maksudnya bila the test statistic is large, so kita akan reject hash note. Bila reject hash note, kita akan accept that the correlation matrix is not an identity matrix. Okay, so we can proceed with the factor analysis. The value of the test statistic of the Bartlett ni, dia ada formula dia, tapi no need for you to memorize or to calculate the value, the test statistic of Bartlett ni. Usually we can extract from the SPSS software. Okay, later I will show you how to compute the value of the Bartlett test of severity using SPSS software. Okay, so kita proceed. If the hypothesis that the population correlation matrix is an identity cannot be rejected, kalau kita fail to reject hash note, the use of the factor model should be reconsidered. So kita kena we cannot proceed with the factor analysis kalau hash note is accepted. Okay, fail to reject hash note. Okay, this is a additional knowledge info. Okay, benda sama je actually. Bartlett test used to determine whether the correlation between items are good enough for factor analysis to be conducted. Okay, in the null hypothesis, the correlation matrix is an identity matrix. Okay, only if hash note is rejected, then the only factor analysis is to be conducted. So, like I said just now, hash note adalah the correlation matrix is an identity matrix. So kita nak reject hash note. If hash note is rejected, then we can say that the correlation matrix is not an identity matrix. So we can proceed with factor analysis. Okay, clear? That is the Bartlett test. The second method to check whether we can proceed with the factor analysis or not adalah using the value of KMO, which is the Kaiser-Meyer-Olkin measure of the sampling adequacy. It is an index for comparing the magnitude of the observed correlation coefficient to the magnitude of the partial correlation coefficient. So kita nak tengok correlation matrix jugalah, whether there is correlate between the variables. The closer the KMO measure to 1, indicate a sizable sampling adequacy. 0.8 and higher are great, 0.7 is acceptable, 0.6 is mediocre, 0.6 above lah maksudnya, less than 0.5 is unacceptable. So the rule of thumb for KMO value adalah more than or equal to 0.6. Okay, if the value of KMO is more than or equal to 0.6, we can say that the factor analysis can be conducted. If it is less than 0.5, we cannot conduct the factor analysis. Maybe the correlation, maybe there is no correlation between the variables. Okay, kalau dibaca the third info here, reasonably large values are needed for a good factor analysis. Okay, small KMO value indicate that a factor analysis of the variables may not be a good idea. So we have three methods actually to see whether there is a correlation between the variables or not. First, we can observe using the correlation matrix. Yang kedua, kita boleh gunakan Bartlett test. Nak confirmkan lagi, boleh gunakan Bartlett test dan juga KMO value. Okay, so this is dia punya degree of common variance using the KMO value. Like I said just now, if the value is more than or equal to 6, okay, so we can consider the factor analysis can be proceeded. If below than that, so we cannot proceed with the factor analysis. Okay, let's see the example. I take this example from the past year actually. Past year, January 2018. A survey was conducted to first year local university students related to factor influence in learning mathematics. Respondents were asked to complete a set of questionnaire containing 14 questions. Okay, factor analysis was done by the researcher on the pilot study of 50 respondents. Okay, based on the appendix, answer the following question. So from this situation of the case study, we can know that we have 14 variables. Okay, because of 14 questions, we have 14 variables, and we want to know factor analysis can be proceeded or not. And then from the factor analysis, we can know whether which variables ataupun how many factors will be represent these 14 questions, and then which questions belong to which component. Nanti kita boleh check. So first of all, before we proceed with the factor analysis, we need to check whether factor analysis can be conducted or not by using the value of KMO dan juga Bartlett test. Okay, so this is the output from the SPSS software, output of KMO and Bartlett test. Okay, so we see the Bartlett value, okay, 2651. So dia punya P value adalah 0. So kita boleh buat, we can conduct the test. It will be like this. Hash naught is correlation matrix an identity matrix. Hash 1 correlation matrix is not an identity matrix. Okay, we compare the p-value with alpha 0.05. Since p-value less than alpha, so hash naught is rejected. So we can conclude of hash 1, which is the correlation matrix, is not an identity matrix, so there is an intercorrelation between the variables. Therefore, factor analysis is appropriate to be conducted to using the Bartlett test. How about the value of KMO? The value of KMO is 0.732. Okay, according to the rule of thumb of the KMO value, which is more than 0.6, we can accept, right? So what can we conclude here? KMO value, because of KMO value is more than 0.6, so factor analysis is appropriate for this data. So because of the proof from these two methods, so we can proceed with factor analysis actually. Okay, so that is the first step. So the second step is we can know how many components should be retained. Okay, berapa banyak factor that can we extract to represent all the variables. Okay, ada tiga cara sebenarnya. So, the first one, using the Kaiser's rule, which is through the value of eigenvalues is more than one. Kan, ya, semua ni you have learned before this actually. Just to remind balik or to recall balik the step in factor analysis. So the first method is using the value of the eigenvalues over 1. If the value of eigenvalues more than 1, we can check whether how many variables how many eigenvalues that have the value more than 1. So kita akan tengoklah berapa banyak number of eigenvalues more than 1. So that will be the number of component that will represent all the variables. Yang kedua, kita boleh gunakan value of the proportion of the variance, kan? Kita akan check the cumulative proportion of variance. Yang ketiga, gunakan script plot. Okay. Okay, let's see the example from the same question tadi. Because of we can proceed dengan factor analysis. So, kita proceed dengan soalan B. Based on the appropriate output, determine how many factor were extracted. Sketch a script plot and suggest the number of factor extracted. Ini yang tadilah. Kan? Kita boleh gunakan this method. According, depends pada output apa yang diberi. Okay, so let's say this is the output given. Okay, from this output, we can see the value of the eigenvalue. Kan kat sini. The first column here, initial eigenvalues. All this value adalah nilai eigenvalues. Kalau kita tengok kat sini, komponen ada 14 actually. Sebab kita ada tadi 14 variables, akan ada 14 component. So, from these 14 variables, how many factor will be extract from this? How many factor that can be represent all the variables? So, we can check using the value of eigenvalues. Okay, if we can see here, these four eigenvalue that having the value of more than 1. So we can say that 4 factors were extracted. Okay, 4 factors will be extracted to represent all the 14 variables. Okay, yang kedua tadi soalannya nak tengok create the script plot. From the script plot also we can see how many factor can be extracted ataupun how many component can be extracted for the data. Okay, so you can plot the script plot. You can draw the script plot. Kat sini x-axis 1 until 14 sebab kita ada 14 lambda tadi kan, eigenvalues, 14 variables, and then is the value of lambda, kan, the value of lambda. Y-axis. Okay, so what can we observe from here? You kena tengok dia punya elbow, betul tak? Elbow dia dekat sini actually, dekat lambda component 5, and then we will accept 4, kan, dia factor that before 5, which is 4. Ataupun lagi senang, you tengok je kat sini eigenvalues 1, you draw the line here, so you akan dapat 1, 2, 3, 4. Akan ada 4 eigenvalues that more than 1. So we are saying that 4 factors will be extracted. That is consistent with the previous decision tadi. Okay, using the value of eigenvalues more than 1. Alright. Okay, kita proceed dengan the next question. Kita habiskanlah. Ini adalah dia punya soalan ni, biasanya pun dia akan step of the factor analysis. Set the cumulative percentage of the total variance. Okay, cumulative total variance explained by the factor extracted. Maksudnya, you kena tengok cumulative percentage of the total variance from 4 factor. Sebab tadi kan kita dah pilih 4 factor. So it will be here 74.78. Kan, cumulative untuk factor, 4 factor. So how can you interpret the value of the cumulative total variance? It will be 74.78% of the total variance explained by the 4 factors. Last kali, by using the factor loading cut off point 0.7, kat sini dia dah bagi dia punya cut off point untuk factor loading to identify the variable for each factor and give a suitable name for the factors. So tadi kan kita extract 4 komponen. So sekarang ni kita nak tahu which variable belong to which component or which factor. Kita ada 14 tadi. Nak distribute kepada 4 factor. Okay, so we can create the rotated component matrix. Okay, akan ada 4 komponen here. 1, 2, 3, 4. Sebab kita dah extract 4 komponen tadi. Okay. And then, from here, kita boleh tengok dia punya factor loading. So, tadi dia bagi cut off point factor loading adalah 0.7. Okay, 0.7, you boleh tengoklah the first component, which questions or which variable that have the loading is more than 0.7. So it will belong to the component. So soalan pertama sehingga keempat will be in the first component. Question number 5 until number 8 will be in the second component. This 3 will be in the third component. This 3 will be in the fourth component. Okay, so next step, you dah ada variable that belong to each component. Then the next step, you need to rename the component as the description for each of the variable that represent all the variables. So you kena tengok lah dia punya variables ni. Okay, untuk komponen pertama, dia punya variable receiving a homework, given a quiz, taking final exam, thinking about the upcoming math. Semuanya berkenaan dengan math ni. So you boleh create the special name for the first component and so on. Okay. So here the suggestion of the name for the 4 factor here. First factor. Actually, the name for each of the factor, it depends pada researcher nak letak nama apa yang suitable for each of the component. So kat sini letak the first one tadi, math evaluation anxiety ataupun math assessment. Okay, sebab apa? Berkenaan dengan quiz, dengan test, final exam. So it will be the evaluation ataupun assessment. Yang kedua, math self-efficacy. Can we see kenapa dia kata macam tu? Sebab dia tanya soalannya adalah I believe I can learn well. I believe I am the type of the person who can do mathematics. I feel I will be able to do well. So ini adalah tahap dia punya confidence ataupun efficacy in mathematics. Faktor yang ketiga, kenapa diletak sebagai math self concept ataupun self awareness? Because of these questions asked, if I do not learn better, I believe it is my fault. If I have a correct learning pattern, I will learn better. If I study hard enough, I can understand the content. So it can be in the third component, which is the self-awareness. The fourth one adalah math learning anxiety, which is having to use the math formula, watching a teacher on algebraic equation, listening to a lecture in math class. So we can represent it as the math learning anxiety. Ataupun the researcher or you can name the factors or the component by your own, as long as it describe all the variables that belong to that factor. Okay, so I hope you clear the start in the factor analysis that you can apply in your project or apply in the situation in your fieldwork nanti.